Today we looked at the fundamentals of exercise for nutrition, what to eat, when, and why. There were poll questions on how much ATP we always have in our body. The correct answer is 2 to 4 seconds because sometimes we just need to move before our physiology gets the message that we need to start breaking down glucose or glycogen. We also have creatine phosphate that supplies us with ATP for high-intensity, short-duration activities. We talked about the Quarry Cycle, or the recycling of glucose. During high-intensity, short-duration activities, lactic acid builds up in the muscle because in the absence of oxygen, glucose cannot completely break down and give us a lot of ATP. So it builds up in the muscle, causing muscle cramping, which makes you slow down, which is what it's supposed to do. Then you get oxygen in the muscle and it feels better, but the muscle doesn't have the enzymes to do anything with lactic acid or lactate, so it leaves the muscle and goes to the liver, where it gets recycled back to glucose. This is called the Quarry Cycle. The anaerobic production of energy is that incomplete breakdown of glycogen in the cytoplasm. Again, in the absence of oxygen, pyruvate cannot enter into the mitochondria. Review this in the videos. So we get energy from pyruvate or from lactic acid. It goes from one 3-carbon molecule to another 3-carbon molecule that provides us with a small amount of ATP per molecule, but sufficient for anaerobic activities. Hitting the wall occurs when the muscles are depleted of glycogen. And this occurs usually, I'm told, around mile 20 of the Boston Marathon, or I guess any marathon. What happens is the muscles are no longer providing glycogen or glucose for aerobic or anaerobic activity. Basically, the person is running on fumes, whatever they can get while they're still in motion. Looked at how the fuels for exercise change during the intensity and duration of the exercise. Fat is used for lower intensity, longer duration exercise. It's an efficient source of ATP because we have these fatty acids that are broken down into 2-carbon fragments that can enter into the mitochondria. That's in the presence of oxygen in aerobic activity. Your questions are an important part of this topic, so please make sure you review them. Then we went over some different activities, looking at what fuel was used, why that fuel was used. This is the summary slide about the different activities, the different intensities, the different durations, and the different fuels that are used. There's a difference between aerobic and anaerobic activities. And in anaerobic activities, you can use ATP creatine. You can also use carbohydrate, but it's an incomplete breakdown of carbohydrate. It can't enter the mitochondria, but it forms lactic acid. But in the presence of oxygen, that glucose can enter into the mitochondria as pyruvate. It forms acetyl-CoA, and you get a lot more ATP. And you also get a lot of ATP from the 2-carbon fragments of fatty acids from fat. Lots of information, folks. Please review it and ask me if any questions you may have when you have a chance to come up for air. Coming up next week, we'll be looking at water-soluble and fat-soluble vitamins. The sales pitch will be on Wednesday, the 21st, which is also the last day that I'll review your diet projects with you. The following week, your diet projects are due, so I need your journals by this Friday. I hope to return your exams over the weekend. You have a week to review them for any grade changes you may have, but of course you can always ask me about them throughout the rest of the semester. Be well, good luck. Bye-bye.